I have started the streaming. So okay, Leela, city session is finished or is going on right now? Okay, let's wait for some 2 minutes. Okay, people are joining. So from 6 5 we will start this session. All right then. Okay, so let me start the session. So, uh, so can you see my screen? Is my screen visible to all of you? Yes. No. Okay. Fine. Yeah. Okay. So uh, how many of you have like watched the lecture video till week 4? You can thumbs up. I will get an idea. No one? Okay, so I have collected some questions, some set of questions, uh, which are related to concepts of week 1 and week 2. Okay, so first we will see the questions. Okay, so at the same time we will discuss the concepts as well. Okay, so very first question is like you have to identify what is the which one is the correct option, which will describe the difference between population and sample. Okay, so just read out the options and let me know which one should be the correct. So first option is saying sample is the entire group, but population is a subset of the sample which is used to describe the parameters of the sample. Second is sample and population are synonyms of the each other. Third one is population is the entire group while sample is a subset of the population which is used to describe the parameters of the population. So as per you, which option should be correct? Okay, option C. Anybody else? I got one vote for option number C. You can unmute, no problem. Okay, option number C. C. I got three votes for option number C. C. Okay. Yeah. So basically, option number C is the correct. So basically, population is nothing but is the entire group, but sample is the subset of the your population. For example, or you can define the what do you mean by the entire group? Basically, you can simply define your population. So 1 minute. Yeah. So you can define your population like it's nothing but total collection of all the elements in which we are interested. Like this is the meaning of entire group. It's nothing but total collection of all the elements that we are interested in. Okay. For example, you can take like suppose you want to do some study on the marks study on the marks of class 10th students of class 10 throughout the India. So what will be your population? Your population will be all the students who are in class 10 all over the India, right? So that will be your population, and sample will be let's say you are going to select some 200 students randomly throughout the India, right? So that will be your sample. So basically sample is nothing but subset of your population. So by notation you can define like this. Suppose this is the big set. Okay, let me draw something like that. uh, okay, so these are some, let's say you can say some balls of different color. Okay, collection of balls of different color. And so this is, suppose this is the total collection of balls of different color in a shop and all. So this will be considered as a population. Okay, and what will be sample? Sample is nothing but a subset of your population. Okay, so for example, let's say I have taken some set of like this. Okay, I let's see. Okay, so what is this? This is nothing but a subset of your this population data set. So this will considered as a sample. Okay. Okay. So before going to that, can you tell me whether this sample is the good representative of my population or not? This subset. Okay. So Isika is saying no. Why? Is there any reason why it's not a good representative?
Sir, I think that most of the groups are not included.
Are not included. Yeah. So basically here actually see, this is anyway, this is a sample for my population data set, but sample should be your good representative for your population data set. For example, let me take another example. Okay, suppose there is a university. Okay, in that university I'm interested to know, let's say annual average package, something like that. And in that university, suppose there are some different, some four different departments. Okay, for example, let's say you can take there is one department of, let's say, English. Okay, another department of, let's say, some science. Okay, another department of, let's say, from uh, Hindi, and another, let's say, you can take any another other department, let's say some Let's take for simply for some, let's say some management courses, something like that. Okay. So suppose there are some students, let's say X1 students, X2 students, X3 students, X4 students. Right? Okay. So to conduct my study, suppose I have taken randomly a set of, let's say, some 50 students. Okay. But only from, let's say, from English department, and these students are only from English department and science department. Okay. So now, okay, by using the previous information, can you tell me this is a good representative or not? This sample, whether this sample, suppose this is my population data, okay, in a university, let's say that is a ABC, any kind of, but this sample, tell me this will be good representative or not? Yes, no,
No,
no, right? Because okay, why? Reason?
we are selecting only from two groups.
Yeah, correct. I have taken the sample only from two departments. Suppose these 50 students which I selected randomly, these all are from these all four departments, right? Let's say some are from English, some are from science, some are from Hindi department, and some are from let's say any management study and all. Okay, now so this sample will I will consider as a, basically it's a good representative for my population data set. Okay, so is this clear, this concept of sample and population? So yeah, great. Okay, so you can whenever you have doubt, just unmute yourself and you can ask the question. Okay, there's not any problem. Okay, so next question, okay, so is this fine, right? I'm going with the questions so that you will get some idea how you can apply the same concept in questions. Okay. So next question is, a study has been conducted to examine whether the students who had applied for MA Triple E entrance exam in 2020 are willing to write the exam in the coming week or not. A group of 10,000 students were randomly selected from the urban areas of India for this study. It is concluded that roughly 80% of the students want to write the exam. So based on this information, we have to answer the following question. I mean, question number 2, 3, and 4. So what is the question number 2? Question number 2 is saying you have to identify sample and population from the given uh, information. Okay. Okay. So just read the options and tell me which should be the correct option. Let me read out options. So first option saying this sample consists of students from across all India. Okay. And population consists of students from the urban areas of India. Option number B, the sample consists of students from the urban areas of the India, and the population consists of students from all across India.
A option wrong, sir.
Okay, fine. I need okay. So just read all the options and do let me know which one is the correct.
Sir, please
The
share the screen.
yeah. Someone. Okay, so you can unmute if you have an answer, because every time if I'll go on the chat box, it will be little bit difficult to.
B, B, sir, option.
Okay, so I got one vote for B, and from the chat box, I got two votes for option number D. Any other
No, D.
D? Okay. Kiran Chandra, you can unmute. Okay. Whenever you doubt, you can unmute and keep mute yourself. Okay. So actually, option number D is the correct. Okay. Why option number B? It's clearly mentioned we have selected 10,000 students from the urban areas of for this history, right? While option number B, what is saying? The sample consists of students from urban areas. That means what? You are going to select all the students from urban areas, right? That is not a correct. In the
Okay,
question,
okay, understood, sir. Understood.
got it? Yeah. So basically, sample consists of the selected 10,000 students from the urban areas of the India, and population will be students from across all across the India, right? Basically, population we have discussed just a few minutes before. Population nothing but total collection of all the elements that we are interested in. Here we are interested in students throughout the India. Okay. So option number D is the correct. Okay, so tell me which about this question. You have to identify the correct statement. Aforementioned conclusion made on the basis of the sample is correct. Aforementioned conclusion is correct because the sample is not a good representative. Sample is good representation of the population.
B.
Okay, I got one vote for B. What about others? Okay, should I go to the question?
Yes, sir.
Okay. So there is the conclusion is roughly 80% of the students want to write the exam. This is conclusion they have made. Okay. So based on this information, answer the
B.
B. Okay. Two votes for option number B. Any other? If you are not getting at any time, right, do let me know. Okay. So option number B is the correct here. Okay. So why? If you see, the conclusion is not correct because the sample is not a good representation of the population. Okay. So sample is not a good representation of the population. Why?
Only the urban students were considered.
Urban students are taken.
Correct, correct. Basically, suppose this is your population all is throughout the India, right? This is suppose this is your urban areas, okay, and these are the students from rural area. So what they have collected in the sample, they have selected 10,000 students only from the urban areas, right? So here this sample is not a good representative. Okay, so this will be good representative only when these 10,000 students are randomly selected from urban areas of India as well as from the rural areas of the India. Okay, so this concept is clear to all of you.
Yes, sir.
Okay,
So
fine,
how the
great.
multiple select questions are evaluated? Like if there are three, two answers, but I selected three. So what will happen? So like multiple select questions, how they are evaluated?
Okay, so for multiple selected question, let me clarify. If suppose there is any question, right? Okay, suppose okay, let's say for this example, suppose this is MSQ. Okay, multiple select question. So suppose, okay, it's also possible if it's MSQ, there, I mean, only one option can be correct also, right? More than one, I mean, at least one option should be correct, right? Now, suppose in this question, for example, B and C are correct, okay? And you have selected A, B, C all, then you will get 0, okay? Because you have selected one wrong option. For example, B and C are the correct option. You have selected any one, either B or either C. You will get the half marks of the, I mean, half weightage of that question. Like suppose, for example, this question is carrying weightage of 2 marks. Then 1 marks will be for this option, 1 marks will be this option. Any one of option, if you have selected, you will get 1 mark. If you selected these two as correct, you will get 2 marks. If you selected any other along with these two, but then you will get the 0 marks. Okay.
Okay, any wrong question will become then whole zero.
Yes,
Any
yes,
wrong
yes.
wrong
Any
selection.
wrong, any wrong. Okay.
Okay, so even if we select one and if it is right, then we will get half
Yes,
out
yes,
of
yes, yes,
two.
yes. You will get half. Yeah.
Thank you, sir.
Okay. So let's move to the next part of the question. Okay, so what can we say about the nature of a study, whether the study is descriptive or inferential? Let me go to the question. Okay, by reading this question, tell me whether the nature of the study is descriptive or inferential.
It is inferential
It is inferential. Why?
because it is giving some information from the data.
Mm-hmm.
Conclusion information, inference.
Inference. What about others? Yeah, feel free to say if you are wrong. Don't worry. Okay, we can discuss it. If you will not speak, I will not able to get whether you are getting the concept or not. So it will be simply. I will assume. I mean, everyone is getting. Okay. So please feel free to ask doubt at any point. Okay.
Because they concluded an inference that 80% of the students want to write the exam.
Yeah. So here inference. Okay. So conclusion is important, but conclusion for population data set. Are you getting? Okay, let me okay. Everyone got the idea behind descriptive and inferential? Yes or no?
Yes, sir. Yes,
Okay.
sir.
So basically
Mm,
descriptive statistics, and there are two kind of statistics, descriptive and inferential. Okay.
Inferential.
So basically what happens in descriptive, whatever data set you
Descriptive
have, basically
data.
in the case of descriptive statistics, what we are doing, we are describing or we are giving description or we are summarizing the data set. Okay. So what is the meaning of description or summarization of your data set? Basically, basically we are doing nothing but we are, I mean, to sum up the main points of your data set. Okay, suppose your data set of marks of some 10 students. Okay, then what you can do for your data set, how you can describe, you can simply
Say
say,
if
you can simply say,
students of 12th standard got this much marks in this subject.
okay, let me complete it first. Okay. So suppose what we are doing in descriptive statistics, okay. So how you can describe the data set? Okay, suppose you have marks of some 40 student, 10 student. You can simply say maximum marks is, let's say, 80, minimum marks is something, right? Average marks is something. You can plot any bar chart, any pie chart, something like that, regional wise and all, right? Yes or no? So basically, what you are doing, you are just summarizing your data set. You are just describing your data set. Okay. Suppose someone gave to you data set. I asked, give me the summary of data set. Okay. That is something you can represent in front of me, right? Now, this is suppose whatever data set you have just summarized your data set and nothing. Okay, let's change the scenario. Okay, suppose you have you can take this. We can go with this example itself. Okay, suppose you want to do HD all over the students of all over the India, whether they want to write the MA exam or not. Okay, what they have done, they have collected a sample of 10,000 students, right? Yeah, yes or no? Based on this 10,000 students, they have done their study, asked whether they are interested to give the exam or not, something like that. Okay, and they got 80% of students wants to give the exam. Okay, now this is your one of the sample, right? Okay, so in inferential statistics, what we are doing, we are making the conclusion, we are inferring something for my population data set. Okay, based on the sample. So based on this 10,000 students, what they have make the conclusion, they 80% of the students wants to write the exam. So this is something they have inferred or they have made the conclusion based on this sample data. Okay, so basically inferential statistics I can perform only on the sample data, not population data, because based on the sample data in inferential statistics, we are making some conclusion for my population data set. Okay, for let's say create another example. Suppose in an university or in a college there are some 2,000 students. Okay, for example. Okay, and suppose this is your population data. Okay, and you want to know what is the average marks in that college. Okay, suppose you are an analyst, you are interested to know what is the average marks in that college. Now suppose it's difficult to know the right all the marks of all 2000 students and all. Suppose you collected some sample of 100 students. Okay. Now you have calculated the average marks based on this 100 students. You got, let's say, some 75. Okay. Now, okay. First of all, tell me, if I have stopped here, like I have marks of 100 students, I calculate average marks is 75, and I told you, okay, focus on my statement. Suppose I'm saying, I like suppose I'm saying to you, average marks of this 100 student is 75. So whether it's the inferential or descriptive, average marks of this
Descriptive.
100 is descriptive, right? Why descriptive?
Because you mentioned it is for the 100 students. If you said it, the average marks of all the
Correct, 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 correct. Because see, okay, what I have done here, I have just described this data set. I mean, describe the data set of 100 students, right? Okay. Suppose you took the sample of 100 students and you have calculated the average marks. You have calculated the maximum marks for this 100 student, minimum marks, something like that. You have plotted some pie chart by, let's say, regional wise students and all, something like that. Okay, and you stopped. Okay, that means this is descriptive, means you have described your data set of marks of this 100 student. Okay, are you getting? For example, after this, suppose you have made the conclusion, like average marks of all the students of the college, let's say this college ABC is 75, then it will be inferential statistics. Okay, because based on this sample data set, you have made a conclusion, you have inferred something about through about your population data set. Okay, so basically descriptive I can perform on population and sample, that is whatever data set I have, but inferential I can perform only on the sample data set. Is this clear? Yes, no? Is this clear to all of you?
Yes.
Yes.
Great, great. Okay, so there is a different question. I mean, so Karthik wants to start a soup production company. Okay, meanwhile, every one of you watched the lectures video, right? I'm assuming that. How many of you covered the lectures which you till week 4? I mean, it will be easy, like you can get the idea, you'll be able to. Okay, one. You can raise your hand. I don't will. I will be have some count. Okay, two of you, three. Only three of you have watched the lecture video. Okay, four. Okay, Prina, how many weeks you have covered? Two. Okay. Okay, how many of you covered till week 3? Week 2? At least week 2.
I covered, sir.
Okay, fine. So for at least 2, there are 7 votes. Okay, 8 are people. Okay, okay, so no problem. I think majority has covered at least 2, not all has. Okay, no problem. Okay, so we'll see the questions first from till week 2. Okay, so okay, meanwhile, so I will take the questions till week 2. After that, I will discuss the concept from week 3 onwards. Okay. So, okay. So, Karthik wants to start a soup production company for all the Indian market to analyze public preferences. He has a team of market researchers. Okay. Who, Kiran, whenever you doubt, please unmute. There was some background noise. Okay. Please take care of this. So to analyze the public preferences, he hires a team of market researchers who conduct the market research in two states, Andhra Pradesh and Maharashtra. The market research team prepares a form to collect the data, and collected data is shown in the following table. So based on this information, we have to give the answers of the, there are some questions. So here data are, I mean, here your table is about name, age, shoe material, purpose, price range, and suggestions. Okay. Now, so very first question is saying, uh, so till which week we have to prepare for the exams? All weeks, all 12 weeks. So very first question is saying which of the collected data is unstructured? Okay. Whether name, shoe material, price range, and suggestions. Okay. Name, shoe material, price range, and suggestions. So question is whether name, shoe material, price range, and suggestions, which of these is unstructured data? Yeah, please tell me. Which of these will be unstructured?
Suggestions.
Suggestion.
Okay. I got some 2 to 3 votes for suggestions. Why not price range and shoe material, or yes or no?
Suggestions are in the raw format, while purpose and price range are have categories, fixed categories flowing.
Fixed category. Okay. Yeah. Basically, okay. What's the definition of structured and unstructured data? Okay. So basically, structured and unstructured data is nothing but, like, see, structured data is something which are already in any no predefined manner. Okay. This structured data is already in a clearly defined and searchable types of data. You can simply say it's a something clearly defined and searchable types of data. What do you mean by searchable types of data? Means I can analyze or I can search any information clearly, right, in an easy way. While unstructured data is already something, these are all are stored in its native format. Okay. And this structured data is something you can say it's a, I mean, I told you it's a easy to search, right, and analyze, right? While unstructured data, it requires more work, very, I mean, it is require more effort to process and something understand. Okay. And this structured data, it's in predefined format, and unstructured data is all a variety of formats. I mean, there is not any predefined formats. Okay. So if you see in the question, price range and all, how it's a, like, it's a, if you see, it's in standard format, right? There is some category, right? It's a, let's say, high, medium, low. Okay. Suppose I ask, tell me the name of the person who is preferring medium. So you can simply tell me Joseph is preferring medium price range, Chris is preferring, Yamini is preferring, something like that. Okay. So structured data should be in predefined manner. Okay. While unstructured data is not any predefined manner. Okay. For example, the unstructured data, you can say YouTube comment, right? So YouTube comments, it's not any in predefined manner. Yes or no? These all are something it will require to more work to process and understand any information from the comments, right? Are you getting difference between structured and unstructured data?
Yes.
Sir.
Okay. So should we move to the next part? Okay. The structured and unstructured data is clear. Or should I take any different example? Clear? Okay. Let me take example. Suppose you will be able to know. Suppose I'm saying, let's say Rohit is a student. Okay. and he is from, let's say, Delhi, and he is doing, let's say, MBA, okay, and his contact number is, let's say, some 9832 something, okay. Same, suppose I'm saying Suman is a student from, let's say, Bihar, okay, and something C is doing, okay, MSc, and her contact number is some, let's say, 7832 and so on, something like. Similarly, suppose I'm saying some, Ram is a student, and same information, he is from some, let's say, from Chandigarh or Punjab or Haryana, and he is doing, let's say, BSc, and his contact number is something like. Okay. Now suppose this is something, some textual data, okay, some qualitative data, some heavy text format data is given to you. I ask, tell me the contact number of Suman or contact number of Rohit. So okay, suppose they ask contact number of Suman, then it will require more effort to tell me the contact number of Suman, right? Because it's not, it's basically in heavy text format, right? It's not in uh, clearly defined or any predefined manner. Yes or no? Okay. So if there is something like data, you can consider as unstructured data. Now the same information, suppose it's given as the name, okay, and state, okay, what degree he or she holds, and contact number, okay. Suppose these are some column names, okay. So suppose the name is Rohit, and state Delhi, okay, degree MBA, contact number something. Then same Suman, Bihar, MSc, and contact number of this, okay. Then Ram, okay, something, something, something. Now I ask, tell me the contact number of Suman or contact number of Rohit. Now from here, you can easily search the information, right? You can simply tell me the contact number of Suman, right? Yes or no? So now you can see this data is in standard format. It's in a predefined format. Yes or no? So this type of data you can consider as a structured data set. Is this clear?
Yeah.
Okay. So suggestions is the unstructured data. Now, so next question is saying, which of the following is are cases or observations for the given data set? Name, Satya, Mayur, plastic, formal, price, range. Okay. Tell me which will be the cases.
Price range.
Divya has raised hand. Divya, do you have any query? Okay, okay. Okay, so price range, why price range? Okay, what is the case or observation first of all? How will you define the case or observation?
The case is like the heading of like name and price range.
Name and price range. Okay.
The
You are saying,
observation is the value,
okay.
like Satya, Mayur.
Okay. Anybody else? Name and price range, you are saying it's a case or observation. Okay. See, first of all, let me tell you, case or observations is a unit from which your data are collected. And row represents cases. Yes or no? So, and cases or observations are nothing but these are a unit from which data is collected. Okay. And let me tell you another things. And one thing's called variable. Okay. So variable is something that varies, right? and column represents the variables. Okay. Now, if you see here, someone told me name and price range are the cases. No, name is the variable. Okay, because column represents the variable, name is the variable, price range is the variable. Because if you see in the under the name column, all values are varying or not, right? Rahul, Joseph, Satya, Yamini, Asi, something. Price range, things are varying. Yes or no? So name and price range are not keys or observation. These are variables. Age is a variable. Shoe material is a variable. Purpose is a variable. Okay. So column represents the variable. What is the case or observation? These are the unit. It's the unit from which our data is collected. Okay. Now tell me, for Rahul, data is collected, right? Yes or no? For Rahul, data is collected. And row represents the cases. Actually, for Rahul, data is collected. For Rahul, what is the age, what kind of shoe material he is preferring, what is the purpose, and what is the price range he is preferring. Yes or no? Same for Joseph, age, rubber, sports, medium. So for Joseph, these data are collected, right? Not for sports, these data are collected. Yes or no? Are you getting my point? So basically, case or observation is unique from which data is collected, and cases is something it should be unique. Okay. So if you see, is there any repetition of Rahul? No, right? All names are unique in this case, right? Yes or no? So basically, Rahul is the case. Satya is a case, because suppose I told you row represents the cases. Okay, suppose I asked you, tell me the Rahul what kind of price range he is preferring, right? Then you can simply tell me high, right? Or suppose I tell you, I ask, tell me the name of the person who is preferring high price range. Now then you are not able to, I mean, you can't say so with certainty whether I'm asking about Rahul, whether I'm asking about Ashish, whether I'm asking about, I mean, only these two are high. Okay, suppose I am asking, tell me the name of person who is preferring medium price range. So you are not sure whether I'm talking about Joseph, Krish, Yamini, Soeb, or Satvik, right? Are you sure? No. So basically, cases should be the unique. Now, for example, suppose I asked, tell me the price range preferred by the Mayur. You can simply tell me for Mayur, he is preferring low price range, right? Yes or no? So basically, cases should be the unique, and row represents the cases. So here itself, if you see, so this row, all row basically, the row represents the cases. So Rahul is the case, Joseph is a case, Satya is a case, Chris is a case, Yamini is a case. Is this clear? Okay. So basically, Satya, Mayur is a case here. B and C are correct. Not plastic and formal. Because if you see, plastic is what? These, if you see, these all are not unique, right? Formal is also not unique, and we have to keep in mind case is a unit from which your data is collected. I mean, for Chris, these all data are collected, right? Not for plastic, data is collected. For plastic, Chris is there, 29 is there. Yes or no? Is this clear to everyone? Okay, fine. Yeah. Okay, so yes, yeah,
I have a doubt, sir.
yeah, please go ahead.
So, sir, if in MSQ I choose more number of answers and those number of answers also include right and wrong questions, so what will be my mark?
You will get 0.
Okay.
Because suppose this is MSQ question, okay? Here B and C are correct options, right? Okay. Suppose you have selected E also, you will get the 0. Okay. For example, B and C are correct. Okay, you have selected only B. you will get the half weightage of that question. Suppose this question is of weightage 2 marks, then you will get 1 mark because you have selected one of the correct option. Any wrong option in MSQ, you will get 0. Clear?
Okay.
Yeah, fine. So let's move to the next part. In order to forecast tomorrow's temperature in Mumbai, the India Meteorological Department collects the temperature, humidity, rainfall of the Mumbai for all days from past 3 months. What kind of data is this? Whether it's a time series or cross-sectional?
Time series.
Time series. Why time series? Option is the correct.
Because
Time.
the data is collected for
Correct,
this
correct, correct.
period of time.
So time series data is nothing but whenever you are collecting your data set over the time, okay? And cross sectional data is nothing but you are collecting the data at the same time, right? Yes or no? So here if you see the department is collecting the data from past 3 months. So they are collecting the data over the time, okay? So for example, you can take, let's say you are collecting the data for Delhi, okay, let's say for 7 days of a, okay, of a month, or let's say of a week, okay. So for Delhi, you have collected the data on Sunday. On Sunday, temperature is this, let's say x Celsius. On Monday, y Celsius. Same for Tuesday. So here I am collecting the data over the time. So this is something called the time series data. What about cross sectional data? Suppose on Sunday, okay, so your time is the, I'm going to consider the same time. Okay, let's say on Sunday, what is the temperature in, let's say Delhi, in Chennai, in Punjab, or something like that. So if you see, time is the same. Okay, okay. So this kind of data I can consider as a cross-sectional data set. Okay, is this clear? Is this clear? So next question is, a courier service interested in knowing customer feedback. The customers are being given the following options to choose from: not satisfied, somewhat unsatisfied, neutral, satisfied, very satisfied. What scale of measurement has been used here? Okay, tell me what kind of which scale of measurement will you will use? Nominal, ordinal, interval, and ratio.
Interval.
Interval. I got
Nominal.
nominal. Okay, what about others?
Ordinal.
I got
There's an
one vote for ordinal data set. Okay. Any other?
Ordinal, sir.
Ordinal. Okay. Okay. So basically, ordinal is the correct option here. Why? Okay. So first of all, I can't use interval or ratio here. Okay. Because this data is nothing but it's a categorical data, right? Okay. So there are two kind of data: categorical and numerical data. Okay. So if I have categorical data, okay. So let me draw here. Suppose I have data, okay. So I will be having two kind of data: categorical and another way is numerical, right? Okay. How will you identify which one is the categorical or which one is the numerical? So basically on the categorical data, I cannot perform any mathematical operation. Any meaningful mathematical operation I'm not able to perform, okay. Basically, but I can use numbers, let's say for coding, for labeling the things, for labeling the categories and all, but I can't perform meaningful mathematical operation. Same for numerical data, but numerical data I can perform the mathematical operation on the numerical data. Okay. Now for categorical data, let's say what kind of, okay, tell me whether gender, gender is categorical or numerical? Let's say female and male. It's a categorical data, right? Okay. You can't perform any meaningful mathematical operation, right? Okay. What about Aadhaar card number? It's categorical or numerical?
Categorical.
Why? Why not? Because Aadhaar card numbers are in numbers, right? In
Yeah,
digits.
but it is number. It could have been alphabets also.
No, forget about alphabets. Aadhaar card is it's all about some 12-digit numbers.
Yeah, but we are not going to do plus or minus in that.
Correct. And we can't perform. There is not any meaningful mathematical operation, right? You can't say addition of your Aadhaar card number or mine Aadhaar card number is equal to someone else, right? I mean, we are not able to. These other notations, basically, those numbers are using just for some labeling the thing. For example, suppose I have labeled female as 1, male as 0, right? Even though these are in numbers, but you can't say 1 plus 0 equal to 1 here. Yes or no? So those kind of data on which I'm not able to perform any meaningful mathematical operation, it will be considered as a categorical data. Okay. So for the categorical data set, okay. So there are two kind of scale of measurement. We can use nominal and ordinal. Okay. And for numerical data set, we can use interval or ratio. Okay. So if there is any categorical data, okay, so you can't select options related to interval or ratio. Okay. So we can use only nominal and ordinal. Nominal scale of measurement is used when there is only labeling is there. Okay. We cannot order. Okay. I mean, we cannot think about any kind of order for in between the categories. Ordinal is there. Ordinal is something there is labeling and as well as ordering is there. Okay. I can order the data set. For example, here you can see, okay, tell me the customer feedback is categorical or numerical first of all?
Categorical.
It's a categorical, right? You can't perform any meaningful mathematical operation. Now, since it's a categorical, there will be only two scales of measurement, either nominal or ordinal. Now, if you see, is there any order between the categories, these categories? Is there order, any order?
Yes, sir.
Yeah, it's the order, right? You can simply say not satisfied, then somewhat unsatisfied, then neutral, then satisfied, then very satisfied. Yes or no? Okay. For example, so this is something ordinal data set. This is categorical data set, but this is something I can order. So this will consider as an ordinal data set. Okay. For example, I'm saying suppose you have some t-shirt sizes. Okay. Let's say small, medium, large, extra large. Now tell me, this is a ordinal or nominal?
Ordinal.
Ordinal, right? I can make a order
Yes.
in between, right? Small, medium, then large, then XL, or in reverse also XL, large, then medium, then small. Yes or no? Right? For example, if you I took the example of let's say female and male. Okay, there are some data. Now it's a ordinal or a nominal?
It's nominal.
It's a nominal, right? You can't order in between, right? Is this clear?
Yes.
Okay. So ordinal is the correct option for the above one. Okay. So I think we have covered the concept. Okay. What about interval and ratio? How will you identify which one is the interval and ratio scale of measurement? What's the key difference in between these two? First of all,
In interval scale, there is no absolute zero value, and in ratio, there is absolute zero value. It exists.
okay, what do you mean by okay? First of all, interval and ratio scale of measurement I can use for the numerical data set, right? And yeah, so that means I can perform addition, subtraction, multiplication, division, and all. But there is one property called absolute zero property. Okay. So absolute zero property in interval scale of measurement, absolute zero property is not present. Okay. For interval, while for the ratio it's present. Okay. What do you mean by absolute zero property? Suppose I'm saying absolute, I mean, what do you mean by? So basically absence of a particular thing. Okay. Whenever I'm saying absolute zero, that means absence of that particular thing. Suppose I'm saying zero number of pen in a shop. That means there is absence of the, I mean, there is not any pen present in the shop, right? Let's say absence number, let's say zero number of laptops, zero number of books. That means there is not any book. Yes or no? But okay, so when absolute zero property fails, that means there is something meaning of that zero. Okay, for example, I'm saying 0 degree Celsius temperature. So is that I mean, is this mean there is no temperature? Can we say there is no temperature? Yes or no? We can't, right? We can't say 0 degree Celsius temperature means there is not there is no temperature, right? So absolute zero property fails. Okay, so whenever absolute zero property fails, so I can apply the interval scale of measurement. And if there is absolute zero property is fulfilled, I will say ratio scale of measurement. Okay, for example, let me take you. Okay, why we are able to perform in only plus and I mean addition and subtraction in interval? So there is one reason, because of absence of, you know, absolute zero property. Okay, why? I will tell you. Okay, suppose okay in, okay, tell me in, I think in degree Celsius minus 273 is the lower temperature, right? Correct or no? Suppose this is the 0, suppose this is the 20, suppose this is the 40. Okay, suppose the amount of heat or amount of temperature from minus 273 to 20 is A, and minus 273 to 40 is B. Now can you tell me, can I say B is the 2 times of A? Can I say this one? Yes or no? Yeah, please feel free to say. Otherwise, I'm not able to get whether you are getting the concept or not. Whether is this,
No,
I can say B is the 2 times of A.
No.
Why? Because of this 0, right? Yes or no? B is not 2 times of A because of this absence of, because here 0 means there is something meaning. I mean here values that I mean in interval scale of measurement, values can be below the 0. Yes or no? Because see, if there is absence of absolute 0, that means things can take values in negative also. Okay, okay, so here, that's why here I'm not able to perform like this. Let's say I can't say B by 2 is equal to, not, I mean this is also is not satisfied, right? So in interval scale of measurement I can perform only addition and subtraction. While let's say come to the ratio. Okay, now tell me, let's say suppose there is scenario of marks. Okay, suppose minimum marks is 0, maximum is 100, whatever. Suppose this is the 20 marks. Okay, for example, so this is the 20, and suppose this is the somewhat 40 is there. Now suppose a student B got 20 marks, A got 40 marks. Okay, now can I say is the 2 times A got the marks 2 times than B? Yes or no?
Yes.
Or B marks of B is half of than A? Not like this. Yes or no? Basically, why we are saying, because there is absolute zero property. Okay, the values cannot go below this. Yes or no? Okay, so keep in mind this absolute zero property. Okay, is this clear? And one more thing, in case of in weak content, there is one concept called discrete data and continuous data. Okay. So what about in discrete data? Discrete data is something, it can take value only distinct values. Okay. I mean, I can count. It's a countable. Okay. For example, let's say number of people in a room, number of laptops in a shop, or something like that. I mean, I can count, and it will take distinct value on a real number line. Let's say this value, this value, this value, this value. It will take distinct value, and it cannot take any value between an interval. I mean, it cannot take value between these two. Okay. It cannot take any value between these two. I mean, basically, it is taking only distinct value on real number line. While a continuous data is something I cannot count. It's not countable. It's only measurement is there. Okay, measurement is there, and it can take any value in an interval. Okay, so let's say, for example, I'm saying height of a person. Okay, now tell me, height of a person you can count, or you have to measure in some, let's say, feet or inches. You have to measure, right?
Continuous data.
Yeah, it's a continuous data. Weight of a person, you have to measure in kilogram, something like that, right? You can't count the weight, right? So measurement means there will be some unit and all. Okay. Okay. Tell me speed of a vehicle, whether it's a countable or it's a discrete or continuous. Yeah, speed of vehicle.
Continuous.
Why? Suppose I'm saying speed of vehicle, let's say some 23 kilometer per hour. You have given the data set 45 kilometer per hour. Some, let's say, and let's say 40 kilometer. Now tell me, this is discrete or continuous?
Still, it's continuous.
Yeah, still, because we have to measure the speed in kilometer per hour, right? We can't count the speed. Okay. Okay. So far, it is clear to all of you. Week one is content. Okay. So all of you have pen and paper. Yes or no? Okay, great. Okay, so let's move to the week two content. Okay, so week one content is clear to all of you. Any doubt? We are going to move to the week two content. Is this clear? Yes, no, any doubt? Okay, okay, great. Yeah, you can unmute if you have any doubt and all of it. Okay, so let's move to the question, week two. So very first question is saying, this table is shows the causes of death in a city hospital in 2019. So you have to find this. How many deaths happened in city hospital in 2019? So this table gives you information about number of deaths, relative frequency. Okay, by using the concept of relative frequency, you have to you have to identify, or you have to find out the total number of deaths in city hospital in 2019. Okay, so just solve it. I will be back in 2 minutes. Hello. Is there anyone who got the
1000.
1000?
Yeah.
Okay. What about others? What about other people?
So 1000.
1000. Okay. Okay. How did you compute it? I mean, what is by using the concept of relative frequency, right?
Yes.
Yes,
Okay.
sir.
So basically, frequency. Okay, there is two things: frequency and relative frequency. So frequency just a representation of the, you know, count of the things, right? And relative frequency is nothing but ratio. Basically, relative frequency is nothing but ratio of the RF means relative frequency. I'm writing in short. So frequency, it's a ratio of frequency to the total number of observations. Here, capital N represents the total number of observations. And this total number of observations, this N is nothing but basically addition of all the frequencies. Yes or no? Okay, the addition of all the frequency. And why, okay, why we are interested in relative frequency, why we are moving to the relative frequency?
As a comparative to.
Comparative to, yeah, to compare the two different data set, because for, okay, for the same for two different data set, your frequencies can be same, right? But relative frequency will be the different, then you can simply compare the data set. Okay. So as I told you, relative frequency for any ith row is nothing but frequency of that row divided by total number of observations, right? Now we have to find the total number of death here, and means total number of observation. Here we are interested to find the total number of death. So what it will be? It will be frequency divided by R of I, right? I means any for any, I mean, for any whether for cancer, accident, heart disease, okay, any kind of thing. So I can find with the anyone. So if you see, what is the, I can use this or this, because frequency is given to me, relative frequency is given to me. I have to find the total number. If you see 300 divided by 0.3 is nothing but how much? 1000, right? You can this 1000 find out from here itself. 250 divided by 0.25, which is again 1000. Okay, so 1000 is the total number of observation or total number of deaths happen in the city. Okay, is this clear? Okay, find out the value of the Z. Okay, what will the value of Z? Okay, so Z is this. You have to calculate the value of Z. How will you calculate? Tell me. There is one concept. Since it's a ratio, right, relative frequency, so sum of all the relative frequency will be 1. Okay, so how will you proceed? First of all, to find the relative frequency of Z, I mean value of Z, basically Z is nothing but relative frequency for the heart digit.
First, you have to find T.
T,
So
okay,
T is 0.150.
and I can use the concept of summation of all the frequency is equal to
Yeah.
1. Okay, so what is the value of T? T is nothing but relative frequency. Okay, so relative frequency is what? Frequency divided by total number of observations. So frequency for cancer is 150. What is the total number of N? I mean value of N? 1000. That means 0.15. That is the relative frequency for cancer, right? I'm writing RFC. Now we have the value of T, which is 0.150. Now to find the value of Z, if you see, we know sum of all the relative frequencies how much? Going to be 1. Okay, so value of Z will be 0.150 plus 0.175 plus Z plus 0.25 plus 0.3 equal to 1, right? And
Yes.
value of G will be here from 1 minus sum of all
0.47.
this. How much?
0.4. No. No, no. After subtracting 0.475.
475.
No, 0.475.
25.
Z equal to 0.475. No. Okay, I think I made a mistake.
Okay, okay.
Point
Basically,
125.
let me add these all things. So 0.15, basically 150 plus 0.175 plus 0.25 plus 0.3. It will be 0.875. Okay. So 1 minus 0.15 is nothing but 0.125. So this is the correct option. Okay. Okay. Suppose I ask the value of y, then how will you compute? This is 0.125 now I got, right? So we know relative frequency is nothing but frequency divided by total number of observations. So what is the y? Y is nothing but frequency. So frequency will be what? Relative frequency into total number of observations. So relative frequency is 0.125 into 1000. So it will be 125. So y will be 125. Suppose I ask what is the value of x. So you can simply add all the observation and you can subtract from the 1000. Yes or no? Or another thing is, this is the relative frequency is given to you. You can simply multiply the total number of observations. You will get the frequency for accidents. Is this clear?
Yes, sir.
Okay, fine. So next question is if an analyst wants to represent the revenues of the various companies using graphs, then which of the following graphical see, can you mute yourself please? There is some background noise. So question says if an analyst wants to represent the revenues of various companies using graphs, then which of the following graphical representation each oblique are most appropriate for this purpose? Purpose is to represent the revenue of various companies. So options are a pie chart with a pie slices for each company and the width corresponding to its revenue, a bar chart with the bar for each company on the x-axis and the length corresponding to its revenue in the crore rupees on the y-axis, and option C, a bar chart with a bar for each company on the y-axis and length corresponding to its revenue on the crores rupees on the x-axis, and a bar chart with the minimum revenue as a baseline. Tell me which option should be correct.
B.
Okay, I got one vote for B. What about other?
B as well.
Okay,
B.
B. Okay. Okay, why not pie chart?
Pie chart, the total has to be a, if pie chart should be parts of a whole. This is not parts of a whole.
It
Okay,
shows the percentage value.
yes.
We have the accurate value in crores.
Okay, okay. So basically, the key difference is bar chart and pie chart is nothing but bar is something when I'm interested to show the count, right? Like for first bar, what is the count or something like that. And pie chart is useful when I'm interested to show the share, right? So for example, here actually B and C both are the correct. I will tell you why C as well. So let me go to here. So analyst interested to show the revenues of the right. Suppose this is there are some three companies A, B, C. Okay, so this is x-axis represents the companies. Let's say this is the zero and some crore rupees is there, some unit. I don't know. Let's say this is represent the revenues in crore. Okay, so yeah. So for company A, let's say this is the revenue. For company B, this is the revenue. For company C, let's say this is the revenue, right? So bar chart is useful in showing the revenue of that company. Okay. Now I can do in reverse also, right? Yes or no? I can represent the bars, I mean companies on the x-axis, sorry, y-axis, and revenues on the x-axis. Yes or no? Okay. So actually both option B and C are the correct. Pie chart is not useful because pie chart is something when we are interested to show the share of a whole, right? Share of a something, right? It should represent the parts of whole. Okay. For example, let me take, suppose there are some three companies, okay, A, B, and C. Okay. Or let's say any other, let's say D. Okay, so for this company, suppose someone is, suppose this company is manufacturing some item X. This company is also item X and item X, item X. Okay. Now, suppose an analyst interested to know what is the sales distribution. Okay, I mean total sale of these four companies. Okay, so I mean basically he wants to compare the for this item what is the sales percentage in a year, same for this company B, company C, company D. Okay, so I can use the pie chart or not, right? In this scenario, pie chart will be useful. Let's say for company A, there are some X percentage of sales. For company B, Y percentage. For company C, Z percentage. For company D, let's say some W percent. Yes or no? So basically, these are nothing but parts of whole. Yes or no? And summation of all this should be 100%. Yes or no? Or you can simply say, suppose you are interested to know the for a single company, or you want to see the sales of each item for a business. Business means suppose there is a company, analyst wants to know what is the sales distribution of the items in a company, something like that. Okay, so basically, whenever you are interested to compare the parts of whole, right, rather than count, pie chart is the useful, and summation of all these slices should be 100%. Okay, is this clear? Is this clear to all of you till this
Yes.
point? Okay, fine. Okay, tell me which of the following can be defined for both nominal and ordinal data. Which option should be correct? For nominal and ordinal data, which one I can use? Mean, median, mode, or all of the above?
Mode.
Mode. Okay. What about others?
Mean and median.
Mean and median.
Median and mode.
Okay. Median and mode.
Median and mode.
Median and
Mode.
mode. Okay. So tell me. Okay. First of all, only mode is correct option. I will tell you why. Okay. Those who told me mean and median, can you tell me why? Why you have chosen the mean and median? Yeah, feel free to say. Only then we are able to know where you are making mistake. No worries. Okay. So okay. Those who, okay. So who told me mode? Only mode.
It's me.
Okay. Okay, Nivida. Can you tell me why you selected mode? Why not median or mean?
Median requires ordering of the data, right?
Okay.
And not everything is ordered. Only ordinal data is in some order.
Yeah.
Nominal does.
Yeah. First of all, try to evaluate the option, right? Eliminate the option first of all. Mean I can't use because nominal and ordinal data means I can use only for the categorical kind of things, right? And mean categorical means I'm not able to perform any, we can't perform any mathematical operation, right? But if you see to calculate the mean, what we have to add all the observation, divide the number of observations, but we can't do, right? For can you do something female plus male divided by 4? Is this making any sense? No. So mean we can't do. Let's come to the median and mode. Basically, median is what we have to arrange the data, okay, in ascending order or descending order. Then we have to find the median. Okay, if it's odd, we can take the middle one or something like that. But for categorical data, even though in it's in even number, so we have to take any one of the from the middle. Okay. So median is I can use only for the ordinal data because okay, let's say let's come to this part. Suppose I have t-shirt sizes. Let's say small, medium, small, large, medium, large. Okay. Now, first of all, I have to arrange the data set, right? So it will be small, medium, large, and large, right? Okay. So what is the median? Median says it divides the data in two equal parts, right? So what is the middle observation? Is the M, right? Because if you see these three, so middle is the M. So your median is the M. Okay. And what is the mod? Means which occur more frequently. What is the mod? Tell me which will be the mod.
S. S.
Yes. because S occurring more number of times, right? Now, if you see this for, okay, now tell me, suppose if there is some data set, let's say female, male, male, female, male. Okay, okay, this is the nominal data. We cannot order, right? And this one was the ordinal data. Okay, now tell me, can I arrange this one? No, we can't arrange. Tell me what is the, then I can't find the median. If I'm not able to arrange, that means I can't find the median. Tell me what is the mod? Mod is what?
M.
M, right? So if you see mod is useful, I can use the mod for nominal data set as well as for ordinal data set, while median is useful only for ordinal data set in case of categorical data. Is this clear?
Yes.
Okay, fine. So let's move to the next part of the question. The share of the Indian telecom market is plotted as the pie chart, which is shown as the below. So we have to choose the correct options. Okay. So options are, the pie chart is not a misleading graph. The pie chart is misleading. The pie chart has round off errors. And the slices of the pie do not add up to 100%. Mod of the data set is Reliance Geo. Okay. So let me, so tell me which option should be the correct. First of all, is this misleading?
The numbers are not clear. It is 20. What is in
Okay,
the
okay,
order?
one second. Let me write down. This is the 37%. Okay. This is the 27%. This is the 9%. And this is the 27%. That's fine. So tell me, is this a misleading? Or what do you mean by the misleading or area principle?
It does not add up
Some
to.
should be 100. Some should be 100.
It's not adding up to 100. 14.
It is, I think.
It is adding.
It is
It's a
adding.
100. First of all. Okay. Let me tell you what do you mean by the misleading. Misleading or area principle says, first of all, let me clear that one, area principle. So area principle says the area occupied by the part of the graph should correspond to the amount of the data. Area, let me write down the area occupied by the,
No.
okay, area occupied by a part of the graph, okay, should correspond to amount of data. Amount of data it represents. Okay. Now, what do you mean by, now? Okay, what I mean by this statement? If you see, so this 30 orange region is actually represents the 37%, right? This blue is 27%. This blue is 20. Green is 20. This is 9%. For example, suppose I'm saying like this. Okay. This one. Okay, suppose this is the like this, and suppose this is the, okay. Let me erase this one. Okay, suppose for example, suppose I'm saying like this. Okay, suppose I'm saying this is the 27%, this is the 37%, this is the 9%, this is the 20, some let's say 27%. Now, is this correct?
Yes, it is.
No.
This 27 and that 27 don't look similar.
No,
Don't
sir.
look same,
27
because
looks
area,
smaller.
or simply I can say, suppose I'm, okay, somehow suppose I'm saying this is the this one is the, let's say this one is the 9%. Okay, suppose this is the 27%. Now tell me, is this area principle is following here or
No.
not? It's a
No.
misleading graph, right? Because if you see the area occupied by the graph, it is not representing the amount of data it represents, right? Yes or no? So first of all, this should you have to take care of this, and it's, so the pie chart is not a misleading. So first option is the correct. Come to the second part. Okay, this is the incorrect because it's a contradiction of the first. pie chart has round off errors. So what round off errors is saying, sum of all the, basically sum of all the slices should be equal to 100%. Now if you add 37, 27, 9, 27, it's coming out to be 100%, right? Okay. So basically, I mean, these two are incorrect. The slices up to 100% is coming out to be. What is the round off error? Because suppose you have some data, let's say 37.52% and all, and for somehow, and you have converted rounded of this value up to, let's say, 38%. For example, this is 38% and same. So now you will be getting 101%, right? Okay. But addition should be 100. So this is something called round off error. Okay. Option number is saying mode of the data set is Reliance Geo, which is the correct, because Reliance Geo is the orange part, and which is the widest slice. This is the orange Geo one, right? Okay, so mod is what? Which occur more frequently, more number of times, right? So in pie chart, okay, in pie chart, the widest slice represents the mod, and in bar chart, the longest bar will represent the mod. In this case, suppose I ask what is the mod? So mod will be your B company B. Yes or no? Okay, because it will represent the maximum number of, more number of. Yes or no? Is this clear? Will you able to identify the mod and all from the given chart? Is this clear, right? Or any doubt? Okay, great. So next, last question from week 2 is saying the bar chart in the given figure is misleading because, so you have to identify the due to which region this is the misleading graph.
Not starting from 0.
This line does not start from the 0, right? So basically this is something. Okay, if you see actually in bar chart, baseline should be 0. If you see here, baseline is started from the 20. So option number B is the correct. Okay. Uh, okay, so in okay, this is something called missing baseline, or you can say manipulated y-axis. Okay, truncated graph, misleading graph. Okay, what do you mean by manipulated y-axis? Anybody? Can you tell me what do you mean by manipulated y-axis?
It's starting at 30. Something.
No, Miss, I have done some manipulation on the y-axis, right? Basically, for example, suppose, okay, just consider the same scenario, and I'm saying it is start from 0, then it's, let's say it's a 10, and then let's say it's let's say this is the 20, and then let's say 55, 65, 75. Now this, okay, can you tell me is this manipulate? Okay, so I have done some manipulation on the y-axis, right?
Yes, sir.
If you see, yes or no? Because if you see, there is 0, 10, 20, suddenly it jumps to 55. I don't know why. Okay, due to intuition, how to show the bar and all, due to some intuition, suppose this is something I have done. So basically, this is called the manipulation on the y-axis. I will give you one more example for manipulation on the y-axis. Okay, for example, instead of this, suppose I have this kind of graph. Okay, suppose this is something, and there is a break. Suppose I have represented this break. Now, whether this is manipulated y-axis or not?
No, sir.
No.
No. Why? Because I have clearly shown, clearly mentioned the break on the y-axis, right? So this is not a manipulated y-axis. Okay. Let me take you one another example. So this is one example. Meanwhile, we will share this PDF with you. Okay. This is, you can go through it. So what do you mean by manipulation of y-axis? Basically, there is one concept: expanding or compressing the scale on a graph that can make the changes in the data seem less significant than they actually are. Okay, for example, this you see, if you represent the number of sales for smartphone A and B, okay. So if you see for smartphone A or smartphone B of a local shop, so from this figure, what you can infer? I can simply infer there is a significant amount of cells is there for B and for A. For B it's a 120, for A it's a 80. Yes or no? But for if you see in this graph, I mean they have done some manipulation on the y-axis. They have expanded the y-axis. By seeing this graph, if you see, it's okay at the first glance. If you see, it seems very low sales of smartphone and smartphone B, right? Suppose by intuition you okay, by the first graph you see, I can simply say there is some significant amount of sales for smartphone and smartphone B. But in this graph, it seems low, right? Even the numbers are same, but at the first glance. But there was no need to do that manipulation on the y-axis, to expansion of the y-axis, right? Are you getting this idea? Okay, so this is something called the manipulation of the y-axis. This y-axis has manipulated. Okay, is this clear? Clear to everyone? Any doubt? Okay, fine. Then. So I think we have covered the concept of till week 2, right? Yes or no? Okay. So should we move to the concept of week 3? Okay, one second. Sid, can you mute? Okay, so I mean, see one thing. If you doubt, you can unmute. We don't have any problem. Okay. If you don't have any doubt, you can mute. You can keep mute yourself because. Okay, so let's move to the week 3 content. Okay. Now, so since till week 1 we have seen some what kind of data, descriptive, inferential, no, categorical, numerical, discrete, continuous, and we have some idea about scales of measurement and all. In week 2 we have studied something more regarding the categorical data. Categorical data is representation of the categorical data with bar chart, pie chart, right? And measure of center tendency mean median and mode for the categorical data and all. Okay, we have seen. Now in week 3 we will basically move the same concept, I mean on one level up for the numerical data set. Okay, so for the numerical data set, okay, we have done we have okay, we know how many types of the numerical data set is there.
Discrete and
Two, right?
continuous.
Discrete and continuous, right?
Continuous.
How will you identify discrete? It should be countable, right? And it should take distinct value on real number line, right? And continuous is something we cannot count. It's a measurement is there, right? Measurable type of data set. Now, so to represent the discrete, continuous and all, so to represent the continuous data and all, so I can plot the histogram. Okay. So histogram is something, it's very useful to make the to plot the continuous data. I mean, you can simply plot, I mean, there will be bins on the x-axis, okay, and counts on the y-axis. Okay, bins means suppose this is 0, 10, 20, 30, something like that, up to let's say 100. So there will be a histogram is nothing but it's a, you can simply say continuation of the bars. Okay, yes or no? This is something form of the histogram. You can simply use this on the. So this length of the bars represents the count. Suppose this is 10, this is 15, this is the 20, something like. So this will represent the count length of the bars. Okay, and this represents the axis represents the bins. Okay, while okay, so one good example is like suppose I'm interested to represent the marks data set of students. So I can simply take the bins of marks, right? In bins of 0 to 10 marks, how many students are there? Similarly for the 11 to 20, then 21 to 30, and so on, something like that. We can plot the histogram. Now let's move to the one concept called stem and leaf plot. Okay, so one concept called stem and leaf plot. So how what is the meaning of, I mean, how I can represent the, or what is the form of the stem and leaf plot basically. So there are two separate things. Okay, I mean two separate things means it's a kind of diagram in which each observation. Let me write down the stem and leaf plot. So in this things, what we are doing, each observation is separated in two parts basically. Separated in two parts. You can simply say one is stem and one is leaf. Okay. So basically, let me tell you how you can do. Suppose I have one observation 75, so I can represent this stem and in the leaf. How I will represent? Suppose so key will be given to you. Key means how I'm going to interpret the thing. Suppose I'm saying 7/5. So this will call the stem and this will call the leaf. It means I'm talking about 75. Okay, suppose I have written 7 5. Okay, so this means 75. If suppose I have written comma 8 in the list, that means we have two observations. So okay, this means 75, so we have two observations. What are those? 75 and 78. Suppose in the again I have written something like that. Let's say 1 2 3. That means in this plot I have 75 78, then 81 82 83. Are you getting? In stem and leaf plot you will get the data set always in ascending order, in the form of ascending order. Is this clear? Are you getting some sort of idea? Yes or no? You can unmute because I have to come again here and there. Okay? So you can mute unmute if you are not getting, or if you got the idea. I don't have any problem. Okay. So for example, suppose here itself I have written something like that. Okay, let me write some another one. Let's suppose I'm saying 6 0 1 2. Then let's say 7. Let's say there is something 9, and then 7. Then let's say 2 3 5. Okay, and suppose I have given the key. Key means it will be provided how you to interpret the observation. Suppose 60 means 60. Okay. Now suppose, okay, can you tell me what are the observations from here? Yeah, tell me. Once you will speak, I will then write.
60, 61,
Okay.
62, 69,
Hmm.
82, 83, 85.
61,
Okay. Can I write 70?
No.
We can't write because there is not any leaf for that option case, right? So there is missing observations from 70 to 81. Are you getting? I mean 70 to 79 basically. Okay. Is this clear? So basically key will be provided to you how you have to interpret the information. Like for suppose 3-digit numbers is there, right? So okay, key will be like 601 means 601. So your observation will be like this 112191. So key will be there how you have to interpret the observation from your stem and leaf plot. Is this clear? This some sort of idea you are getting?
Yes, sir.
Okay. So suppose from stem and leaf plot is given to you, I can ask the what is the mode, right? Or what is the median, or what is the mean, right? So from the plots you have to take the all the observation and then simply you can tell me the, okay, tell me what is the median here? Since it's already in ascending order, what will be the median?
The fourth item. So,
Right?
9.
Median is nothing but it divides the data in two equal parts, right? Right? So
so
69 is the
69.
median, right? So there is formula, right? You can go through. I mean, if you have to check whether n is odd or even. Okay. If n is odd, so a median will be which one? N plus 1 by 2th observation, right? Yes or no? So if you see how many observation is there in this case? 33617, right? So 7 plus 1 divided by 2, that means fourth observation. Fourth observation is the 69, which is the median, right? Yeah, it will be shared via mail. Okay, don't worry. Recording and all, YouTube link. If n is even, okay, so median is what? It's the average of n by 2th observation and n by 2 plus 1th observation. Okay. For example, there is one more observation. Let's say 86. So what will the median? Median will be n by 2th. So what is the n here now? N is 8, right? So median will be, so this is even, so I have to use this formula. I have to take the average of 8 by 2, that means fourth observation and fifth observation, right? I have to take the average of 69 and 82, that will be the median of my data set. Is this clear? And mean is something what is nothing but sum of all the observation divided by total number of observations. That is something. Okay, so there is one common term for this mean, median, mode. What is that?
Measures of central
Central
tendency.
tendency.
Okay, measures of central tendency. Now, great. Now tell me why I mean, we are interested in to calculate the mean.
So
Why
the
we?
rest of the data is around that.
Okay. Anybody else? Why we are interested to calculate the mean?
Single represented value of the data.
Correct. It's a single. Suppose you have data set of some 200 students, marks of 200 students, right? Suppose I ask, I want to know some central idea about marks of a data set, or suppose I ask you represent your data set in a single number. Okay, I asked to represent your data in single number, then you can simply tell me average marks of the 200 students is 80. Then I will be having some central idea, right? On an average, students are going to get 80 marks, right? So in this kind of scenario, measures of central tendency is very useful. Okay, let me take one example to tell you. Okay. In which scenario you will prefer the median rather than mean? Tell me.
When data is categorical.
No. I'm asking for numerical data itself. See, median is there, mean is there. Why we are interested to? In which scenario I will prefer the mean or median?
To get the top half of the data and the bottom half.
Okay, that is from inference. Is there any key reason I should prefer the median than mean?
When in data outlier is
See,
there.
the mean is not part of the data set.
Okay. Yeah, someone told me outlier extreme values. Okay,
Yes.
that is the
Yes,
one
sir.
case. Yeah, because suppose this is the data. Okay, what is the mean? Mean it will be 1 plus 2 plus 3 plus 4 plus 5 divided by 5. I think it's 5, 4, 10. 15 divided by 5, which is 3, right? And what is the median for this case data set? It's a 3 itself. Median most observation, right? It's already in ascending order, right? Yes or no? Are you getting?
Yes.
Yes, sir.
Okay. For example, there is one extreme value in my data set. Let's say 1, 2, 1, 2, 3, 4, 5. Let's say 500. Okay. What will the mean of this? So mean will be 510 addition of all this divided by 5, right? 1 not 2, right? And what is the median?
Three.
Median is still 3, right? So you can see simply mean is more sensitive to outliers, right? Because it by one extreme value it got changed, right? There is a significant change in the value of mean, while median is the same. So mean is more sensitive to the outliers while median is not. Okay. So let me go to the some different another example. Okay, let's say I have data set 1, 1, 2, 3. say 3, 4, 4, 3, 7, 7 to 9 to 11. Okay, 11. Let's say 2, 13 to 15. Suppose I have this data set. Okay, for example. Now tell me what is the mod?
2.
What is the median? To find out the median, we have to first arrange. So it will be 1, 1, 2, 2, 2, 3, 4. So median observation is 2, right? Median is
Yes.
2. What is the mean? It will be 1 plus 1, 2, 2, 4, 2, 6, 2, 8, 3, 11, 4, 15 divided by 7, right? Am I right?
Yes, sir.
15 divided by 7, that means uh,
17 divided by 7.
let's make it 3, right? So it will be 3. So 3. So mod is 2. Okay, correct. Median is 2. So it will be 7, 14 divided by 7, which is again 2, right? Right? Okay. Now, okay, so tell me, suppose I want to add a constant. I want to add a constant 4 to all these observations. Okay. Then what will the effect on my mod, median, and mean? Okay. If I want to add, then what will be my new data set? Tell me. It will be 4, not 4, 5, 5, 6,
7.
6, 6, 7, and 7. Now tell me what is the mod? 6. What is the median? 6. And what will be the mean? Mean is what? Again 6, right? You can simply add if 5, 5, 10, 18 and 10, 28, 28 and 14, right? So 28 plus 14 will be 42 divided by 7, which is 6, right? Now there is one property. If you see what is this 6, this 6, can I say it's nothing but 2 plus 4, 2 plus 4, 2 plus 4. Why I have written this? Because this 2, if you see, this is nothing but mod of the old data set, and this is the constant. Yes or no? Same, median of the old data set plus constant, mean of the old data set plus constant. Okay, so basically what is the case? Suppose you have data set x1, x2 up to xn, and you want to add a constant c to all the observations of this data set. Then my new data set will be what? Let's say it represents yi. Then my new data set will be x1 plus c, x2 plus c, something like that. Yes or no? Then suppose I ask what is the mod of new data set. So mod of new data set, or you can simply say new mod, is nothing but old mod plus C. You can do plus C or minus C. Similarly, median of new data set will be what? Old median plus C. Similarly, new mean will be what? Old mean plus C. Is this clear? This property, are you getting? Why it's necessary? Suppose there is some in a class there are some 200 students, right? And class teacher have given the marks, and you know the average marks is, let's say, 50. Suppose there is discrepancy in one question, and teacher wants to award 3 marks to all of the students. And I asked, tell me the average of new data set. So is it good? You are going to collect, you are going to add 3 marks to all the marks of to all the 200 students, and then you are going to calculate the mean. It's a tedious task, right? Or if I know the old mean of the old data set, suppose I know the it's a 50, then I can simply add 3 to the old mean, and I will get the new median. Yes or no? Are you getting? So this property is very helpful for in this kind of scenario. Is this clear? Yes or no? Suppose I want to multiply by a constant. Okay, let's say multiply by a constant, let's say 2 itself, or let's say 3. Okay, so what will be my new data set? So new data will be 3, comma 3, comma 6, 6, 6, 9, 9, right? Now, if you see, so we can see the, observe the property. What will the mod, new mod? It will be 6 again, right? Which is nothing but 2 into 3. Yes or no? New median will be again, it's a 6. Again, I can say 2 into 3. And new means mean of the new data set, which again it will be 6, which is 2 into 3. So now if you see, what is this 2? This 2 is nothing but mod of old data set into constant. Same here, a mod of old, mean of old data set into constant. So in general, what you can say, whenever suppose I have to multiply it by a constant C, I want to multiply by a constant C to all the observations of my old data set x1, x2, let's say xn, then new mod or mod of new data set will be old mod into that constant. Same, new median will be old median into that constant. Similarly, new mean will be old mean into that constant. Is this clear? Till this part, everything is clear to all of you?
Yes.
Fine. Okay. So let's discuss two more concepts and then we can wind up. I think from 8 p.m. you will be having math session, right?
Yeah, Python.
Yeah. Python. Okay, maths is already happened. Or okay, Python is there. Okay, sorry, sir. Python is there, right? Okay. So math was from 4 to 6, right?
Yes, sir.
Okay, fine, no problem. Okay, so next concept called measures of dispersion. Okay, what is this? Why we are interested to calculate measure of dispersion?
How the individual terms are different from the mean.
Okay,
How much scattered apart they are.
basically I'm interested to know the variability of my data set, right? Or how much spreadness is there, right? In that particular data set. Now, what's the need? I mean, is there any? Okay, let me
In
tell
the
you. What's
example
there?
you gave above, that 500 was different from the rest of the data.
Okay. Okay, let me take you one another example. Okay, suppose there is college A and there is college B. In college A, there are some, let's say annual packages of some 5 students, let's say in crore or 10 lakhs or lakhs, whatever. Okay, and in college B, package of some 5 students is this like this. Okay. Now, what is the average annual package? It's 3, and for this, it's again 3. Yes or no? Mean for these two data set, mean is the same, 3 and 3, right? Suppose I tell you, I came to you and I tell you annual average package for college A and college B is the same, which is 3 lakh. In reality, is it true? Is the annual average packages are same? Yes or no?
No.
No, because there is some variability, right? If you see in college A, there is no variability, but for college B, there is variability, right? So variability comes into the picture to know how much spreadness is there in my data set from the mean, right? Suppose I came to you, I told you average annual package is 3, but how much spreadness is there from my average value, right? Okay, so that is for this kind of scenario, variance. There is one terms called the variance. So variance and standard deviation. So basically, there is two kind of formula. First one called the population variance. Okay, and it notation for this is sigma square is nothing but 1 upon n summation of I to n xi minus x bar square. So this xi, all observation, this x bar is in the mean of the data set. Okay, and another is sample variance. Okay, it the notation for is small s square is 1 upon n minus 1 summation of xi minus x bar square. So basically, what you do in the the only difference is n and n minus 1 between population variance and sample variance. In question and all, it will be clearly mentioned whether you have to compute the population variance or sample variance. why these are difference, and also there is logic behind unbiasedness and degree of freedom. That's something we are not going to study here. So you can keep in mind, for population variance in numerator all the observation will be there, and for sample sorry, not numerator, denominator, and for sample variance all the it will be n minus 1. Okay, this is something you can calculate, right? Xi minus x bar. So here you have to do 3 minus 3 whole square, then 3 minus 3 whole square, 3 minus 3 whole square for all 5, and you can add up. So here variance, you can see variability is 0, right? For this case, how will you compute? You can simply write 1, 2, 3, 4, 5, and mean is 3. So you have to do 1 minus 3 square, 2 minus 3 square, 3 minus 3 square, 4 minus 3 square, 5 minus 3 square, add all the observation, divide by. If it asking about population variance, you have to divide by 5. If it asking about sample variance, you can do 4. Till this point, it's clear? Yes or no? Okay. There is one concept called the standard deviation. What is that? Anyone who have watched the lecture video till week 3?
Square root of variance.
Okay, square root of the variance. That's great. But why we are doing square root? If I have the variance, I know the variance is 4. Then what's the point of taking the square root of 4?
It's because the units doesn't match.
Yeah, units play the very important role. What do you mean by units? Suppose you are the data set of weight, right? Weight of some person in kilogram. Then suppose you have calculated the variance of that data set, you will get some variance, let's say x kilogram square, right? But your original data set is in kilogram. But suppose you have calculated the standard deviation, or I will take the square root of this variance, then I will get some square root of x kilogram square, and I will get square root of x kilogram, right? Now, for the standard deviation, if you see, unit is the same as the original data set, right? So basically, it's easy to compare with my original data set. So standard deviation, that's why we are taking the square root. So standard deviation is nothing but square root of the variance. So population standard deviation will be what? Sigma is nothing but square root of sigma square, which is nothing but square root of 1 upon n summation of xi minus x bar square, and sample standard deviation will be, it will be small s, which is nothing but square root of s square, which is nothing but square root of 1 upon n minus 1 summation of xi minus x bar square. Okay, is this clear till this point? Is clear to everyone? Okay.
Yes, sir.
Okay, so
Yes, sir.
we can stop here, right? Because I think Python session is already started, right? Okay, so okay, then let's meet in next session. Okay, we will continue from after this variance and standard deviation topic, right? We'll move to the percentile, quartile, and all. Okay.
Where can we find the practice papers? The one you were discussing, will you be sharing that, sir?
That PDF, question PDF.
Yes.
Okay, okay. I will send to the team. They will share with you. Okay.
Thank you.
Okay, okay, okay.
Thank you.
Thanks. I hope you got the concepts. We'll meet in the next session.
Thank you, sir.
Okay, thanks.
Thank you, sir.
Thank you, sir.
Yeah, thanks. Bye.